subsystem to actually drive the robot around. But if we put this code on the robot would not move.
You don't have any inputs.
We don't have any inputs, and we're not tying them to our subsystem.
Right.
So we're
Also
gonna
commands.
do that next.
Okay.
Now,
So what are we gonna
also
say?
in the interest of time, we're gonna cheat a little bit. I'm gonna say some things that Cedric will understand. Many of you may not, and that's okay, because Cedric will show us what I mean later.
Hopefully understand.
Cedric, I don't want to create any dedicated command classes. I just want to use the lambda expression. And
Okay. Got it.
Yeah.
So we have
Perfect.
real.
Perfect. You can help them out then, right?
Lambda.
So anyways, do you want to do this first?
Delta.
Do you want to do our class declaration first? The subsystems?
Yes.
Yes.
So weird. Actually, memorized.
So before we do anything, we have to actually tell our robot that it has a drive subsystem. Because currently it has no clue. It doesn't know what a drive subsystem is, and it doesn't know that it has one. So in order to declare that, we'll just declare a drive subsystem as a variable. Does anyone have any idea how to start with that? Drive. Yes.
Right.
Kevin.
Whatever we want to name him. God.
Does anyone remember something that we might need to add before the drive, though?
Private.
Right?
Yes, private.
Unholy.
Private drive, and then
God.
what name do you want to name this?
God.
Kevin.
Yes.
Yes.
God, yes, Kevin.
Underscore drive.
Did I hear underscore drive?
Yay.
Yeah, we have a winner. Okay.
This election was rigged.
Okay. Equals, and then just for the interest of time, drive, or new drive, and then our drive IO. Oh wait, actually no, we don't set this here.
What?
We don't initialize it yet.
Declare, don't initialize.
So the reason why we do this is because if you look right here, we have our code set up such that we will initialize a different IO based on if we're doing an actual run of a robot versus a simulation. That's why we have our two classes. We won't run both IOSim and IOVictorSP at the same time. We will run them at different times depending on what mode our robot is in. So for example, in real quick, we'll just have underscore drive will be initialized to new drive, and then the drive IO, which in this scenario will be drive IO VictorSP. But it'll be a new one.
We're nesting our constructors.
We sure are. We have lots of objects and non-objects. And then, does anyone have any idea what we do for sim?
Same thing.
Underscore drive equals new drive IO, whatever the Victor thing, or whatever the simulator thing. Drive,
Yep.
Victor sim.
Oh my gosh. Yeah. Yes. Exactly.
Parentheses, or not, yeah, parentheses, semicolon.
Cover sim. Yep. And then the default is weird.
Default we can skip it now.
I mean, it's sure, I guess. It's just a new drive IO, right?
New drive IO.
It's new drive IO,
New drive
Default.
Then you also need curly braces after the
and then it's yelling at us because we're probably unemployed.
So this is just gonna do nothing.
Kind of, yeah. Basically, if we're not in sim or real, which something is horribly wrong.
If we're not in sim or
Well, it's
real,
replay.
that means we're replaying. the
Replaying,
log.
yeah.
We don't have a log to replay. We're not going to have a log to replay. So we won't really ever be in this default case.
Yes.
But this is how we would implement it.
So-
How did you get
Why
rid of
wouldn't
your
you
error?
just put another
You
case for if you're-
Hover over it, quick fix, and it's probably an import error.
But it's redundant with the default method.
Thank you.
Yes.
Switch cases in Java will yell at you if you don't have default.
Alright, well, I mean, you could just use the default to demonstrate that something went horribly wrong, and none of the three things worked.
Yep, we sure could. But we don't
So
like
that would
throwing.
be another use for the default, and we could just. I
We don't like
Right.
throwing
We could-
errors.
We could do that. We're not going to specifically because, as much as possible, we don't want to throw errors in our code because then our robot stops moving and we sit dead for the rest of the match. We don't look good. We don't have fun.
They're really
We're
sad.
just generally pretty sad.
Yeah, it's happened before.
Scroll up, please.
Okay.
It's just a declaration.
Once you're here, give us a thumbs up. And then Reese, are you good?
I have some errors.
Okay.
Driving starting to not look like a word.
I saw it.
If it'll do it again. It doesn't say connect, and it'll only let me. I'm
Have I told you the I'm grandma story now? Or your grandma story? I'll tell you before.
No, you would be grandma.
Nope, I'm grandma. I'm grandma.
You're too bearded.
Too beardy?
Should be.
You're a good one.
Okay.
Yeah.
Are we good to move on?
I believe so.
Okay.
Thumbs
Thumbs
up.
up. Okay.
Are we gonna go into configure button bindings?
Yes. The formatting was bothering me, so I fixed it.
How did you do that?
If you want to fix your formatting and you have your formatting all set up, just do Control Shift P, or if you're on Mac, Command Shift P, because Macs are weird, and then type Format Document.
But your formatting has to be set up.
Yes. Otherwise, it will not do it correctly. So how do you set it up? You have it set up so it's spaces of 4.
UTF-8 encoding.
Yep, all of this basically. That's all.
I don't like the two braces on the same line. I want the first curly bracket.
The next line.
Yeah, like we've been doing it in.
I don't like it like that.
Right?
You like it? You like it the way that you're used to because you've been taking a class for 2 months.
The way you like it when it's like this.
Like that?
Wait, Josh, you like it when it's like this?
I like
Yeah.
that with the
That's
space
true.
between.
Oh, I hate you.
Our team has done this for years and years and years, and we probably won't be changing this.
One of your lines in the middle.
What's-
all of your lines.
What's really funny is we have a auto formatter. So whenever you build or try to deploy code, which runs the build command, it automatically changes all the stuff back to this.
Well, I'm gonna change the formula so it goes my way.
What's gonna go into configure button bindings, Cedric? I
Well-
would love to know.
Are you ready to move on to configure button bindings?
I'm sure Reese will get caught up.
Yeah, I believe
I
that's
believe in
where we need
Colin's
to put it.
ability to catch
Okay.
him up. And I would like to keep it cooking because we got 30 minutes.
Yep.
Quiet. Thank you.
Believe most people should be ready. One second. Come on, that's it. Okay. Oh, I grab it now. Okay. So, Colin, are you fine with me just typing stuff that people don't understand? That's a default command.
Type stuff people won't understand, and then once it's all written out, we'll explain it.
Sounds good to me.
It's real hard to explain this ahead of time.
You do that, right? And then what's called it? Drive dot.
You'll Cedric, you'll actually need to do a underscore drive
Don't
run
In here?
underscore drive run. Yeah, there you go.
That's weird.
Right.
Drive. You're right. I was blind. Okay. And then it'll be. Oh, we need to set up joysticks first, don't we?
Yep.
Okay.
Here we go.
So, if we go up, we have this little dandy little thing called controller. What controller are we going to use?
Joystick?
A joystick, or are we going to use just the Xbox controller?
Xbox?
Logitech. Okay, private controller. Not controller there. Logitech. Nope. Okay, let's check. General.
Xbox controller?
It's Xbox.
Yeah. Colin, do you remember what the Logitech controller is called?
So what we're gonna use here is just the word joystick.
Okay, I thought we were using a controller.
You can use joystick on a controller.
Okay, that works. Okay, so we now have our joystick. We initialize it here, right? And instantiate.
Do we want the WPI lib one or the Little Thin Robotics one?
I think the WPI lib one.
Oh, go back up.
Oh, sorry.
Okay.
It's just a joystick equals new
Yeah,
joystick.
I was rubbing my eye.
Okay.
Can you go back down to the one before that after this?
Does everyone have the joystick? No?
Thank you.
Okay, Blake and probably. Okay, and then Violet. This is what we had. Violet. Violet? Do you want to see the set different command? Yeah. So we're not done. It's underscore drive dot set default command inside the parentheses, underscore drive dot run inside those parentheses, just a parentheses, and then a small arrow, underscore drive dot drive, and I'm going to do underscore joystick.
That is the error you should. Actually, subject's right now.
Come on.
I believe it's that, right?
You need. Correct.
Yes, but it's negative on the y, I believe.
Yep. Negative y.
So the reason why we have negative get y and get x when you'd expect just get x and get y is because the joysticks on first are really weird. So forward is positive x and left is positive y. Right?
What?
What?
Or is it the robot? Something
um,
along those lines.
That is how they have implemented all of the field positioning stuff on the joysticks themselves. Right is positive X, like you would expect.
Okay.
And this is specific to the joystick itself. But right is positive X, and forward is negative Y.
Oh, I was just wrong. Okay.
Yeah.
So I need some these around.
It's a dash.
No. No, this is right because so the first parameter to your drive function is
Your drive.
Your-
Oh, that's
your
negative.
drive,
Yeah.
and
Never
we're going
mind.
to drive with the Y axis of the joystick.
I had the right idea, the wrong details.
Yes. It's like when you get the right answer, but
The wrong way.
you use the wrong formula.
Yeah. It's like when you create a plate of lasagna using a spaghetti recipe.
That would be very confusing, but not altogether unappreciated.
But back to our spaghetti analogy before. But I believe this should be it for our default command. If we want to see it in one picture more. Oh yeah, that's hard to read.
Second gets that one.
Huh?
It's like when you say two in the last second of a science question, and it's right. And the question was like, how many stars exist?
With luminosity greater than 8. Yep. So that's okay.
Oh, yeah. I see a
That Rubik's Cube object in for which exploded is true. It seems if it exploded.
Okay. So we've written this line of code. Let's talk about what it actually does,
Yes.
because it's kind of weird. So we'll take it piece by piece here. So the first thing that we do is we say drive.set default command. Who remembers back to day one when we said there's two main parts to our robot code. We've got subsystems and we've got
Our system. Our
Commands.
commands, yes. So a command is just an action that a subsystem can perform. So when we say set default command, this is telling our drive base, hey, if you're not actively doing something, you should be doing this command. And so the parameter that we've supplied here is the whole parameter is _drive.run and then a whole bunch of stuff up through one of those last parentheses there. That is the definition of a command, kind of. It's a command. We're cheating a little bit in defining a command using a shorthand notation. This drive.run function, this is something that's built into all subsystems that specifically says in whatever parameter you provide to this run function, that the actual parameter is a function that we're going to call every 20 milliseconds while this command is active. The function this is really where the shorthand comes into play here. So starting with the two parentheses and then the little arrow that we drew there, this is the start of this thing called a lambda function. A lambda function is essentially a shorthand notation for defining a regular function just without having access modifiers, return types, or even a function name. So it's a little bit weird, but essentially the empty parentheses are saying our function has no parameters. The arrow is saying, here's what I'm going to do inside my function. And what we're going to do is we're going to call the drive method on the _drive object. Our drive method has two parameters. This is the drive method that we were working on right when we started tonight. The two parameters are the drive value and the rotate value. So joystick.getY, negative joystick.getY, that's our drive value. That's forward to backward, how much power we're applying. And then the joystick.getX, that's our left to right. So putting all of this together, what we're saying is, hey, drive base, if you are not doing anything, what you should be doing is every 20 milliseconds, call this drive function, and your drive value is going to be forward and backward on my drive joystick, and your rotate value is going to be left to right on my joystick. So we've just crammed a whole bunch into this one line here. Does anyone have any questions on this?
Zach?
What is a lambda function and why are we using it?
So a lambda function is a shorthand notation for really just a regular function. The shorthand notation comes in that you don't have to specify an access modifier, you don't have to specify a return type, you also don't have to specify a name for the function.
Alright, so it's just a kind of do this.
It's a very free-flowing function.
Shortens things up.
Yep.
But it's a lot harder to read.
Yes.
There's a trade-off there.
Yes. Full disclosure, the reason we're using a lambda function instead of a normal function at this point is purely because I want to show you guys something cool tonight. I want to show you the work that you've actually done.
Yep. So this should be, I think, about it for robot container for now.
For now. Let's go to constants.java. We'll need to set our mode to sim.
Oh.
And Cedric, you're gonna need a joystick.
I am going to need a joystick. You're right. Oh boy, lots of comments. So, in order to change your robot to mode, all you need to do is go into constants, and then this line right here, line 25, you just need to change the mode dot to either real or sim, depending on what you want to do. Yes, if you want to simulate it, just put sim, and if you want to run it on a real robot, just run real.
I think we're supposed to do that.
Are we?
You can change if you want to. We're just doing it right now because we're going to be simulating a robot. Very cool.
It'll work.
Yes, but joystick is very, very nice.
Here's your joystick.
Yay. Or your joystick.
Joystick.
Amazing joystick.
Okay. So, Cedric, could you explain how to start the robot simulation?
Not
Or
really.
did you just start it?
I just started it.
Okay. Once
So-
it starts up, close it, and then explain what you did.
Okay, will do. So in order to start a simulation, once you set your robot mode to sim, you do your Control Shift P or Command Shift P, and there will be a command that's called Simulate Robot Code. You click that, it'll build your build everything real quick, and then you click Yes to Sim GUI, Sim GUI, and then you click OK. And then it should launch this little tab right here. Wait, do you see this on your screen? No, you do not. This tab. So this is the simulation tab.
Crazy.
Pops up for a second and then goes away.
Did your code crash?
Maybe.
So if it popped up for a second and then went away, that is likely your code crashing. Alright, so GUI, that was okay. And then that little window will pop up on your computer there. That is showing that everything's running correctly.
It is.
Yeah, you're still, no pointer exception.
Just a second.
Yep.
Can you pull up the drive?
Yep.
So you want that secure underscore info 30.
So there should be inputs and the
Colin, do you want to simulate this in Advantage Scope or in the normal simulator?
What?
Try to simulate this in Advantage Scope or the normal simulator?
So you'll start the simulator and then you'll open up Advantage Scope.
So we want to do Advantage Scope?
Yep.
Okay. Let's move this.
What was the
Oh, wait, it is. It just did it.
Okay, just go here.
This one felt faster than the last one.
So what are we looking for there?
What did you think about the Gradle wrapper jar?
Yeah.
Is it if you
And it's
Yeah.
the version of Gradle that you're using.
I looked at those.
It's just expect different amount of stuff.
I have 190.
So it's good quality.
Oh, you could.
Just to somebody use.
Using
Out on the other side.
All right, Cedric, what are you doing now?
So this application, this initial application, is called Advantage Scope that we touched on earlier. It's basically the way that we actually view all of our simulated stuff and as well as our logged information. So what we can do is, if you have Advantage Scope, which some of you might not,
Advantage Scope should have been installed with the WPI library.
should it? Oh, okay. So you should have Advantage Scope.
Okay, if everyone doesn't know where it is, go to your search bar and type Advantage Scope, and something called Advantage Scope WPI Lib 2024 should pop up.
So if you go to search bar. Oh my god, does it show up on the screen?
Nope.
No? Darn. I can't do that then. Very
Are
sad.
you guys finding it? Raise your hand if you can't find it.
Wait, there we go.
Yeah.
So just search up Advantage Scope, WPI Lib 2024, and you should be able to see it. Pop up.
Were you guys able to find it? It should be probably Advantage Scope. It shouldn't be.
Yep.
It's in your, I don't know where. Where does map go?
In the binder.
Are you good?
Yeah.
You found Advantage Scope.
Should I be opening up
Advantage Scope?
If you guys open your search bar, you have Advantage
or
Scope.
the driver station?
Just simply.
Just the search bar.
Just to do it.
Right, the search bar for
You
your job.
probably don't have the actual driver station.
Probably.
Perfect, just.
Okay.
Yeah, my advantage scope doesn't have.
Oh.
Yep.
Okay.
And it shouldn't
Okay.
by default.
By design.
Mhm.
Okay.
Okay.
So if you have your simulation open and Advantage Scope open, what you're able to do is go to File, and you're able to connect to your simulator.
So push file and go. File and back to.
And then what you're able to do is you're able to go back to your robot simulator, and you're able to change your mode from disconnected or disabled to teleoperated. So now your robot will be effectively enabled.
Really go back there and just keep it on there for a bit. Just.
Yep.
Yep.
Right here.
So you're gonna go to. That's okay. So it might give that error, but that's okay. For the controller, if anyone's saying that they need a controller, it's okay. It'll automatically give that error if there's a controller plugged in, but it's not gonna stop it.
And actually, Cedric, can you show everyone how to get a?
Yeah. So since not everyone here has a controller, what you can do is, I believe this should pop up as default, called System Joysticks. There should be a little box, and then you won't have an Xbox controller, but underneath you'll have keyboard 0, 1, and 2. So just take one of them and drag it.
Pick keyboard 0.
Pick keyboard 0. Why is it not letting me? Oh my gosh, I'm on the wrong tab. I'm so smart. So just drag this keyboard 0. Yep, here. So basically, where it says joystick 0 unassigned, drag it on top, and let go. And now your joystick should be your keyboard, and you're able to control your axes with your.
Yep, joystick is now 1.
It's actually AWE. It's awe. A is your I don't know. Wait. Yeah. Wait, that's weird.
It's probably W and S for your y-axis, A and B for your x-axis, and Q and E for your z-axis.
The z-axis is not very z-axising.
Yeah, we're not using the z-axis.
Oh, it's R.
It's R and E.
Yeah, and it's the throttle,
That's fine. We're not
so it
using
stays the
that.
same. But we're not using it.
This is supposed to be stuff on the graph.
Not yet.
Not yet.
Okay.
So once you're done with that, oh, you see my graph and stuff. But basically, what you need to do is you should have I believe, a line graph by default.
Yep.
And what you do is on the left side here, there should be a tab that's called Advantage Kit. Open Advantage Kit, and then open Drive. And then we should be able to see those 5 attributes that we've been logging.
Yeah.
So drag, for example, front or back left wheel speed and back right wheel speed onto the same axis so it stays the same scale. You're able to actually see them fluctuate with time.
But don't do robot angle because that's always going to be 0.
I mean, you can't do it, but it'll always be 0.
It'll be boring.
Why is it not working, Chad?
Nothing's happening.
You have to have the simulation open in order for the line graph to do anything.
Yep.
Put this window on the left side of your screen. It's a bunch of lines.
Those are AS7.
Nothing is happening.
So if you're on the keyboard, then go to your game. If you go back to your files,
If you click into the left window, now if you realize.
I mean, they started as
You are successfully simulating and driving a virtual robot.
Well, that makes sense because if I'm going forward, it should be
you might need
Like, why are they all the same number? They should be.
you won't be able to do it 3D now.
Okay. Is everyone figuring it out? Raise your hand if you have any trouble.
I can tell you how to do it, but we don't do that.
So this is what your hard work is paid off. Woo!
Whoa.
Yes. Are we gonna get it?
That's my goal.
Okay.
All right,
very weird.
Okay. So, was everyone able to simulate the robot? All right. So with the last 5 minutes here, what we're going to do is we're going to put our code on the actual robot.
Ooh.
So-
Ah.
What we're going to do,
We have 5 minutes. We'll get to put one person's code on there. Maybe 2.
so I'm going to put this box in the middle of the floor here.
So I can't run into anyone's shins.
Yes, exactly.
Already there.
Why are sometimes it's-
Sorry, can
there's no stopping.
Just move, and we're going to set it.
Do you want to turn it?
Yep, we're going to rotate it.
Deleted the line.
Oh, what's like the simulation?
Okay.
The same time, and then click into this.
Pretty simple. So drag it to. So hold on your.
You ready?
Sure.
All right.
Tile
Give it a shot. Okay. So- In the interest of time, because we only have 4 minutes left, what we're going to do here is we are going to get code deployed to the robot, and we're going to show the same code that we wrote working on the actual robot. So in order to deploy code to the robot, first step is the robot has to be on.
Is the robot on?
The robot is not on.
It's not plugged in
I
yet.
plug in the battery, and then I flip the switch.
I'm not needed yet, I guess.
Nope.
I can
Here's
hear.
the connected. Yeah.
While that's booting up, Cedric, can you change the mode back to real?
Yes. So just go to constants. It will no longer be in sim. It will be very real. This is real stuff here. Oh, frick. Good idea.
Is Mila here?
What?
Thank you for laughing.
Just because you
Okay. Okay. Now, the next step to deploying is we need to actually connect to the robot. And when we're at our workshop here, the robot, it's got a radio on it. We talked about that on day 1. That is really just going to act like a different Wi-Fi network that we can connect to. So, Cedric, if you want to,
The biggest issue is if I connect, I will leave the meeting.
that is a problem. All right, Violet, you want to deploy your code?
Sure.
Did you
I changed this back to real.
change it back to you? Perfect. All right. So, Violet, you will need to connect to the robot. Cedric.
Yes. Do you want me to demonstrate what you need to do?
Yes.
So, wait, where's the tabs?
On the main screen.
That's so sad. So,
Actually,
Okay.
most people are going to be able to figure out how to connect to various Wi-Fi networks. Cedric, can you help Violet on your computer connect to the right Wi-Fi network?
Sure.
Should we all connect to
No.
it?
No.
I mean, you could, but
you can, but please don't.
you should.
SB suitcase box?
Yeah. SB. We have a very creative naming convention.
Okay. Now, Violet, once you're connected, just like we simulated our robot code, there will be a similar command called deploy robot code.
Yep. So, Control Shift P. Deploy.
I don't even know what what's the second week? It's gonna be having a dashboard. So I'll pull it up real quick.
I'll pull up on
We
this
need a
screen.
computer
So-
that has the driver station on it, so that we can do that.
Oh,
But the only computers that I know that already have it
are these two computers?
are the ones that are connected to the internet. and need to sit next to the internet. So we'll use this one to drive.
Okay.
Oh, is that the driver station computer?
Okay.
It is 8:30, so if any of my beautiful, amazing sport dog cherubs need to leave, because it's 8:30 and you have a ride, okay? We're still gonna continue to record for a little bit. You can watch this on YouTube tomorrow after I get it uploaded.
This is the dashboard.
Right, that's what I was saying.
This is the dashboard that we'd be creating. It won't be the exact same thing. It will be something similar that will display some of the stuff that we were
And you're making it, but is it-
Yes, we will be making it.
Oh,
Well, there's a base code that basically sets the background, of course.
Bye, Ethan.
But we'd be adding like panels for like various screw drive angles, or not screw drive
For how
angles,
many of
for like
our
powers
geek week
Gotcha.
people
and
are young
angles.
and don't have
and is that
cars?
something you would need the previous code to do? Or
Yeah,
that's
sure.
it?
Probably.
Oh, you're just
Because
I'll just sit in and listen.
We will be making a commit of our code after today. You can just pull that down and start with that tomorrow.
Okay.
So you'll have everything for tomorrow.
Okay.
Or not tomorrow.
Is it personal right back? Like,
Hey guys,
work on something.
we're gonna run it.
All right. So,
it's like
just to recap super quick here.
Things, so it's like
We have
either way.
plugged
it's
in the
better.
battery on the robot. We've
But
turned
I
on the
appreciate it,
robot.
really, I do.
The laptop that has the code, we've connected that to the robot. We've run the deploy command in VS Code. And so now our code is on the robot. The next thing that we need to do is we've got a different laptop here that has the driver station software installed. We didn't go over how to install the actual driver station on day one. It was extra. We didn't need it. You will need it if you want to actually drive a real robot. But I've got it set up. We've got it connected. We've got joysticks plugged in. It says we're connected. We've got robot code. So now what we're going to do is we are going to enable the robot and see what happens. All right, enabling. And all right, so we are seeing the effect of something called a lack of a deadband here. And so what that means is that even though Violet is not pressing on the joystick at all, the joystick isn't perfectly at 0. It's got some low value, and that low value is being applied to our robot. On a real robot, or like a season-specific robot, we would account for that in our code. We aren't going to worry about that right now. All right, so Violet, I want you to press forward on the left side. And so we can see that all of our wheels, they're not spinning at quite the right, or quite the same speed. But our two left wheels are spinning the same speed. Our two right wheels are spinning the same speed, roughly. And the reason they're probably different is just because you might not be pressing directly, perfectly forward on this. Now I want you to press right on the joystick. Yep, okay. So by pressing right, that means we want to be rotating to the right. And if we remember from our diagram, if we're rotating to the right, that means the left wheels are going forward and the right wheels are going backward. So it's driving. What this means is that we can set this robot on the ground. So we're going to lift it up by the handles real quick. Check this out. Set it on the ground. And finally, if you want to drive around really slowly.
I'm trying to get the extension cords out of there. Oh yeah.
Go ahead
Extension cords.
and go backwards. What? There we go.
Yay! Sorry. That's okay.
All right. So many of our students have already left for the night because we're a little bit past our 8:30 closing time here. But for the YouTube video, everything that we learned in this workshop so far is we did go over how our robot code is broken down into subsystems and commands.
The microphone's over here.
Oh, it's over there.
So-
Okay, let me
Yes, this is the microphone. Oh, no, that's the
That's
microphone.
the microphone. So
right.
this video is not going to show up on the YouTube video because it only picks up video that's recording audio as well. So it's the lovely view of this and your shared screen. Just so you know.
Oh, that's unfortunate.
So if we want to stop the robot real quick, so we don't hear Colin's beautiful voice plus. I figured out how to hold it still. Nice.
All right. So to recap, what we've gone over in Geek Week is we talked about how our robot code is split into really two main parts. We've got our commands and we've got our subsystems. We walked through the process of creating a subsystem, and that involves creating the actual business logic, like our control algorithm and how to actually manipulate our hardware. It involves the I/O interface, which is a description of how we interact with the hardware directly. That's where we said, hey, we can power our left side or we can power our right side. And then we created our SIM and Victor SP implementations of that Drive I/O interface. And those were responsible for saying, hey, on a real robot, here's how I turn the left motors on. Here's how I turn the right motors on. And then similarly, on a simulated robot, here's how I turn my left motors on. Here's how I turn my right motors on. From there, we created a command in Robot Container that essentially just said, hey, robot, whenever you're enabled, we want you to be driving according to what the driver's joystick is actually doing. And then we demonstrated actually simulating our robot. We got to show Advantage Scope hooked up to our simulated robot and actually seeing those wheel speeds change as we simulated our robot, which is super cool. That is going to be super beneficial for programmers as we're writing code for the robot before the robot's actually built during the season. And then, of course, the very last thing that we did was we took that same code, put it on the robot, and got to watch it drive around a little bit. All right, before we officially call it, does anyone have any questions? All right, thanks for staying late, everyone. Drive safe.
Woo!